What if the future of space exploration hinges on the power of the atom? What if the answer to the long nights on the moon and the vast distances between planets lies in harnessing nuclear energy? Today, we delve into NASA's ambitious project of bringing nuclear power to the moon. Back in 2022, NASA, in collaboration with the U.S. Department of Energy, announced contracts to three major companies: Lockheed Martin, Westinghouse, and IX, a joint venture of Intuitive Machines and X Energy. Their mission? To design a nuclear fission reactor capable of generating electricity on the moon. This marked the initiation of the Fission Surface Power Project, aiming to provide safe, clean, and reliable energy on the lunar surface. The challenge of the lunar night, lasting about 14.5 Earth days, necessitates a power source that operates independently of the sun. That's where this nuclear reactor comes into play, offering a potential solution for long-term exploration and science efforts on the moon. In the words of Trudy Cordes, Program Director for Technology Demonstration Missions within NASA's Space Technology Mission Directorate, it's an enabling option. This nuclear reactor could prove especially useful at the lunar South Pole. Here, regions that are permanently shadowed are thought to have trapped water ice and other volatiles, resources that future lunar explorers could utilize. Fast forward to 2024, and NASA is wrapping up the design phase of this project. The three partners have submitted their initial designs for a reactor and subsystems, detailed cost estimates, and a development schedule. The next step, refining the project's direction for Phase 2, which involves the final reactor design for a lunar demonstration. Open solicitation for Phase 2 is expected to kick off in 2025. What's the end goal? Delivering a reactor to the launch pad in the early 2030s. The agency has set its sights on a 40-kilowatt reactor that uses low-enriched uranium and weighs no more than 13,200 pounds. To put that into perspective, a 40-kilowatt reactor can provide electrical power for 33 households on average. This reactor plan is part of a broader nuclear vision for space exploration. This includes launching a nuclear-powered spacecraft named Draco by early 2026. Furthermore, NASA has recently awarded contracts for developing more efficient Brayton power converters, which are essential for converting thermal power from nuclear fission into electricity. In summary, the Fission Surface Power Project represents a significant leap forward in our quest to explore the cosmos. By harnessing the power of nuclear energy, we may be able to conquer the challenges posed by the harsh lunar environment and pave the way for sustained human presence on the moon. This project serves as a testament to human ingenuity and our relentless pursuit of knowledge, proving once again that the sky, or rather, the moon, is not the limit.